This video recaps everything you need to do if you missed class today, 8th grade honors math, Wednesday, November 17th. First is the do now. It's on slide 1 of ClassKick. Make sure you have ClassKick open and go ahead and give this question a try. So you should have given questions 1 and 2 a try. There is no question 3 today. And we've been covering unit rate in class. So we know that if a runner travels 500 meters in 100 seconds at that constant rate, we can calculate 2 unit rates. The first unit rate that we can calculate is by dividing 500 by 100 to give us 5 meters per second. We know that this is 5 meters per second because we're dividing the number of meters by the number of seconds. If I flipped my division sentence and instead I divided 100 by 500, I would end up with 1/5 of a second per meter. We could always calculate 2 unit rates for any given proportional situation. We simply need to pay attention to the labels. This is meters per second because we divided meters by seconds, and this is seconds per meter because we divided seconds by meters. Question 2 says, copy and complete the ratio table. When we're working with a ratio table, we know that we'll be multiplying the number of hours worked times some consistent number. It's called a constant of proportionality, every single time to tell us how much money is made. I know that 7 times some number equals 84, which means that I can divide 84 by 7 to find that missing number. And it's 12. You might have known that as a multiplication fact off the top of your head. I know that 1 times 12 is equal to 12. And I know that if I think about how many hours it takes to make $1, that's this row right here, some number times 12 equals 1. I could either divide 1 by 12 to find that missing number, or you might know off the top of your head that it's simply 1 over 12, because if we multiply a unit fraction, 1 over 12, times the whole number in the denominator, 12, we end up with 12 over 12, which is simply 1. In the final row of the table, I know that some number multiplied by 12 is equal to 138, and so I can simply divide 138 divided by 12 to find my missing number, which in this case is 11.5. We have a foundations quiz coming out tomorrow, so if you have any questions about this topic, be sure to reach out to me. Today's learning target is I can draw a line on a coordinate grid given a slope, and I can determine the slope of a line on a coordinate grid. In today's class, we did 10.1, we reviewed some homework and an exit ticket, we did 10.2, and then this should say 10.3 here. We did 10.3 next. You do have homework tonight, so make sure you check out the homework that's posted in Schoology when you're done. If you're watching this video because you missed class, we're going to be skipping 10.1, and we won't do number 3 over Zoom, or rather over this video. Take a look at the exit ticket from lesson 9, lesson 2.9, and see how you feel. And we can always talk about it when you return to school. So like I said, we're going to skip 10.1 if you're out, and we'll start with 10.2. The figure shows 3 right triangles, each with the longest side on the same line. Your teacher will assign you 2 of the triangles, and you need to prove why the triangles are similar. So if you're watching this video, I want you to tell me why triangle ABC is similar to triangle FHG. And you can go ahead and pause this video to answer that question. So you should have given question 1 a try, and there's a few ways to prove that these 2 triangles are similar. The first is looking at the corresponding sides. When I move from 4AB to 2FG, I'm multiplying times 2. And I can see that when I move from CB 3 to HG, I am also dividing by 2 because HG looks like it's just about 1/2. And I think I wrote and said multiplying here, but I meant dividing. So HG is about 1.5. So I have a consistent scale factor between ABC and FGH. That's one way to prove it. The second way to prove it is using the quotients of the side lengths. And this is what we learned on Monday. I know that AB divided by BC, so AB, which is 4, divided by BC, which is 3, is equal to 4/3, or 1 1/3. As a decimal, that would be 1.33. And I know that FG is equal to GH, or 1.5, so 2/1.5. Now, we don't usually have a decimal in a fraction, right? It's not usually included in a fraction. So we can rewrite this fraction, 2 1/5, just by simply multiplying the numerator and the denominator both by 2. And you'll notice that FG over GH is also equal to 4/3. And if you typed either of these into a calculator, you would end up with 1.33333. So we can see that the quotients of the side lengths are the same, which is another way to prove similarity. Now, I want you to go ahead and complete the table in question 2 by listing out the vertical side lengths, horizontal side lengths, and vertical divided by horizontal. You can pause this video to take care of question 2. So in ABC, the vertical side length is 3. We know that the horizontal side length is 4. In FGH, which was the other one we talked about above, we know that the vertical side length is 1.5 and the horizontal side length is 3. And then in this final triangle, CDE, we can see that the vertical side length is 6 and the horizontal side length is 8. And so if you were to divide for any of these questions, the vertical side divided by the horizontal side, you'll always get 0.5. Now notice that another way to write 0.5 would be to say that the vertical side divided by the horizontal side is equal to 3/4. Vertical divided by horizontal is equal to 3/4. And 3/4 is just the reciprocal, or the flipped version. The reciprocal is when we flip the numerator and the denominator of 4/3. 3/4, 4/3. It's just the reciprocal, which makes sense because we just divided in the other order, right? We divided length of vertical by length of horizontal, and up here in question 1, we were doing length of horizontal divided by length of vertical. All right, so in activity 10.2, we were introduced to the formal definition of slope. And this might be a place where you want to take some notes, or you can always add them to your ClassKick document. Slope is a way to measure the direction of a line. And when I say direction, I mean the slant of a line, not the direction in terms of side to side or up and down. The slope is defined as the rise over run. And what I mean by that is for any point on the line, we can always divide the vertical side length of a triangle and the horizontal side length of a triangle that falls along a line to calculate slope. So, for example, right, in this line here, no matter which triangle we pick, as long as we calculate the rise, the vertical distance, divided by the run, we end up with the slope. So the slope of this long line here is 3/4. And the reason why it's 3/4 is because for any triangle that connects with the line as its hypotenuse, the vertical side divided by the horizontal side is 3/4. So let's take a look at 10.3 for some more examples. Draw two lines with a slope of 3. What do you notice about the lines? Well, to draw a line with a slope of 3, I know that I'm going to need to be able to fit a triangle on the line that has a rise over run, or a vertical over horizontal of 3/1. Because remember, 3 is going to be the vertical distance of my triangle that fits along the slope, and 1 is going to be the horizontal distance. And so my line should fit a triangle with a height of 3 and a base of 2. And so then if I use my line tool here and I draw a long line where that triangle uses my line segment as the hypotenuse, I've got a line with a slope of 3. Right? That's this black line right here. And I could do it again because it asks for two lines just in another place in the graph. Right? I could say, okay, over 1 and up 3. And so I can draw another line segment with a slope of 3. As long as that line segment makes the hypotenuse of the triangle. Now notice that these lines are parallel. So that's one thing for what do you notice. But the other thing to notice is that if I created another triangle on this line, let's say I went 3 over and I went 6 up, 9 up, I should say. That would be 9 up to intersect with the black line, right? If I had a triangle here that was 3, 9, my vertical distance, which is 9, over my horizontal distance, which is 3, is still equal to 3. So no matter where you find that slope triangle, the slope does not change, right? So I want you to go ahead and try this slide for question 2. Draw two lines with a slope of 1/2. Remember, this is going to be rise. The vertical is 1 over horizontal is 2. When you're finished with slide 4, you can give 10.4 a try. You're matching slopes of lines. And there's a lesson summary on slide 6. When you're finished with all that, make sure you take a look at the exit ticket for today, which is posted in the Schoology folder, along with tonight's homework.